The status of the electrical generation and distribution system can be displayed on the electrical page of the multifunction display. To select the electrical page, use the Engine and System Integrated Display Control Panel, ESID, and we'll use MFD2. So touch the MFD2 knob to move it to the SYS position. The electrical page is the default page, automatically shown after you select SYS. This indication means that DC external power is connected. Check battery load and voltage to make sure that the DC external power is delivering the correct load. The Electrical Power Control Unit, EPCU, validates it for phase and voltage limits. This means that AC external power is connected and OK. An AC power protection unit ensures that AC external power is within voltage and frequency limits and its ABC phases are OK. Load and temperature for the three batteries are shown here. Load indicates the rate of charge of the battery and is a percentage of maximum load. So 1.00 indicates 100% of maximum load. When in the normal range, there is no plus or minus sign. A plus indicates overcharging, so the main battery is being overcharged at 30% of its maximum load. The auxiliary battery is discharging at 30%, and the standby battery is being charged at 60%. Battery temperature goes amber over 50 degrees centigrade and red over 65 degrees, triggering the three battery hot warnings. On the DC side, you also have the voltage on the left and right essential, main feeder and secondary feeder buses. On the AC side are the voltage and load on the three phases of generator 1 and generator 2. Again, the load is a percentage, so phase A of AC Gen 1 is 60% of maximum, and phase C of Gen 2 is overloaded at 130% of maximum. In the center are load on the APU generator, if installed, load on DC generators 1 and 2, and load on TRUs 1 and 2. Again, all are percentages of maximum. If any electrical figure is invalid, it is replaced by dashes. Note that battery temperature is the only color change on the MFD electrical system page. Note also that, like all other systems, the electrical system page is not displayed automatically if there is an abnormal electrical condition. That's what the crew alerting system is for. You have to select it to see what's happening. On the overhead panel, there are only two panels that control the electrical system: the DC control panel and the AC control panel. The DC control panel lets you charge all three batteries by connecting them to their charging buses: the standby battery by connecting it to the left main feeder bus, the auxiliary battery by connecting it also to the left main feeder bus, and the main battery by connecting it to the right main feeder bus. The switches are inhibited under some conditions, for example if there is a DC bus fault. When the individual battery switches are off, the battery caution lights come on, indicating that the batteries are not being charged. The battery master switch controls the output from the three batteries, not the charging input to the batteries. When in the battery master position, the standby and auxiliary batteries power the left essential bus and the main battery powers the right essential bus. The powering switches are directly connected to the standby, auxiliary and main battery switches. These are the DC generator switches. In the Gen 1 and Gen 2 positions, the generator control units are powering the left and right main feeder buses. In the off position, a generator is isolated from the electrical system, and its DC gen caution light will illuminate. The off position can be used to reset a GCU if a generator is shut down. The DC generators are inhibited if external power is on. External power also has priority over the optional APU. External power powers the main feeder buses only if the EPCU okays its voltage and polarity. The main bus tie switch manually ties the left and right main feeder buses together, or manually separates the main feeder buses. However, the EPCU logic overrides this switch and will prevent invalid conditions. The switch is a manual backup to the EPCU. Holding the bus fault reset switch momentarily in the reset position will re-initialize the EPCU after a bus fault to re-enable bus fault monitoring. The AC control panel just has the external power and AC generator switches. AC external power is validated not by the EPCU, but by a separate external power protection unit, which checks for over and under voltage, over and under frequency, and ABC phase rotation. If valid, it is connected to both variable AC buses. AC external power has priority over the AC generators. The AC gen switches connect the AC generator control units to the AC variable buses. Like the DC system, when a GCU is not powering its AC variable bus, the AC gen caution comes on, and the off position can be used to reset a GCU for circuit monitoring after a generator shutdown. Remember that in the AC system, the GCUs monitor the buses and provide cross-tie. Circuit breaker panels are in several locations: the left lower panel, the left upper panel, the right lower panel, and the right upper panel. Note the coordinate naming system of the four circuit breaker panels. I and O are missing, to avoid confusion with 1 and 0. Refer to your manual for a detailed reference. When a circuit breaker pops out, you are allowed to reset it once only. For the electrical system, there are battery hot warnings, battery cautions, generator hot and TRU hot cautions, generator and TRU cautions, and bus cautions. We'll cover some of these in the abnormal operations lesson.